Good afternoon, everyone. Welcome to the section of B- Basic Mathematics, that is BCS012. Today, we will be talking about something very interesting and calculative. You have to do calculation in that. So I request everyone to have a copy and a pen with you because you have to do it simultaneously when I'm teaching you. Is the screen visible to you? Can you see the screen? Is the slide visible to you?
No, sir.
It's not visible. Okay. Now it is visible.
Yes, sir.
Yes,
Yes,
now it's
yes.
visible.
Okay, fine, fine, fine. Now, today we will be starting with Unit 4, that is your mathematical introduction. We begin with the following question: what is the sum of first and odd natural numbers? If n equals to 1, the sum will be 1, as 1 is only summarized. The answer we see is a formula that will enable us to determine the sum for each value of n without having to add the sum bits. Now, if you see that, we take up my first 10 sums. Here we can see that 135. 135 are odd numbers. Normally, odd number is written as 1 minus 1. Okay. So as you can see that it is Sn equal to, we have to sum the first odd. As you can see in the screen that it is 1. You have to add. We have to add 1, 3, 5, and we are talking about 10 numbers. The last one will be 2n minus 1. When we add up all this, we get n squared. Getting a pattern and then simply jumping to the conclusion that the pattern must be true for all values of n. is not a logically valid method of proof of many instances where the same point the pattern fails. Just because a rule, pattern, or formula I'm audible to you? Okay. Now going back. There are many instances when the pattern appears to be developing for small values of n, and then at the same point the pattern fails. Just because a rule, a pattern or formula seems to work for several values of n, we cannot simply conclude that it is valid for all values of n without going through a legitimate proof. Now the thing is that how to legalize a pattern. One way to legalize the pattern is to use the principle of mathematical induction. We have already seen the formula Sn is equal to 1 plus 3 plus 5 till 2n minus 1, and the sum of these numbers is n squared, where which is valid for 1, 2, 3 till 10. Do we need to compute Sn by adding the first n odd natural numbers? There is basically a method, and we will be talking about that method little bit later. Having obtained the formula, the value of Sn for some integer n, we can obtain the value of Sn plus 1. That means that then this will become n squared plus 2n plus 1, which is nothing but that is n plus 1 whole square. That is Sn is equal to n squared for some natural numbers n. Then the formula holds for the next natural number n plus 1. That means Sn is equal to n squared holds for n is equal to 10. Therefore, it must hold for the next number, that is the 11th number. Since it holds for n is equal to 11, therefore it must also hold for n is equal to 12 until the last number. The principle underlying the foregoing argument is nothing but the principle of mathematical induction. Now, what is principle of mathematical induction? Suppose a statement is involving a natural number n, and the statement is given by Pn. First of all, there are three steps to be followed, and that is a universal rule. We have to follow it in every type of question. First one is P1. Replace n is equal to 1 and you will get what is has to be proved. If that is true, then it will be true for PK. And if it is true for PK, that it will be true for PK plus 1. For every integer of k, that PK must be true for all natural plus n. Now the thing is that, in other words, to prove the statement Pn holds for all natural numbers, we must go through two steps. First, we must prove that P1 is true. Secondly, we must prove that Pk plus 1 is true wherever Pk is true. That means this has to be followed, and I will show you how it is. Now, simple is that. There is, if Pn is a statement, n into n plus 1 is even. Then what is P4? Replace n by 4. You will get 4 into 4 plus 1. That is 5. 4 into 5 is 20. That is an even. Then what is now? See, we have to show that. I'm talking about problem 2. I'm talking about problem number 2, that is, if Pn is a statement n into n plus 1, n plus 2 is divisible by 12, then we have to find P3, P4, P5. And we have to also see in which case the statement is true or is false. If we replace n by 3, that is 3 into 3 plus 1 into 3 plus 4, 3 plus 2, 5, 5 plus 4, 20, 20 into 3 is 60. 60 is divisible by 12. That is correct. Now we replace n by 4. 4 into 4 plus 1 into 4 plus 2. That becomes 120. This is divisible by 12. But what about P5? P5, it becomes 210. And 210 is not divisible by 12. That means we cannot say that n into n plus 1 into n plus 2, whatever the number we keep, that will be divisible by 12. Now, problem number 3, if Pn is the statement nq plus n and is divisible by 3, is the statement P3 true? Is the statement P4 true? Nothing to do. You have to replace n by 3 in the first case. That will become 30. 30 is divisible by 3. But when you are keeping 4 in n cube plus n, it becomes 68, which is not divisible by 3. If P1 is the statement 3 is to the power n is greater than n, then find is you have to find that is that true for P1, P2, and P4. Simply replace n by 1 in the first case, that will be 3 greater than 1, which is true. If you keep n is equal to 2, 9 is greater than 1. That is again true. If you keep n is equal to 4, that is greater than 4, that is again a true statement. Now, if we take this statement, 2 raised to the power n greater than n, is that true for Pn plus 1? So replace n by n plus 1. Straight away you can see that 2n, 2 raised to the power n plus 1 will always be greater than n plus 1. If we have another example of Pn, it says that P3 is true, but P4 is not true. In that case, you have to generate the statement. That will be that your Pn statement will be n is less than equal to 3. In earlier cases, what we were doing, we were just proving it, the statement was given to us. Here, I'm just saying that you have to find the value of Pn such that P3 is true, but P4 is not true. In that case, what will you do? Here you can see n is less than equal to 3, where P3 is true, but P4 is not. Give an example of statement Pn such that it is not true for any n. Let Pn be the statement, that is n into n plus 1 is odd. Now you can see whether that is odd or not for all numbers of n. If you are going to keep n equal to 1, you will get 2. If you are going to keep 2, you are going to get 6. Okay. Now give an example of the statement Pn in which P1, P2, P3 are not true, but P4 is true. That is n greater than equal to 4. These are some of the examples. Now comes actually what we are supposed to do in mathematical induction. As I told you, there are 3 steps to be performed. Now we will see how they are performed and what we are supposed to do actually. There are 3 or 4 types of problem in this particular unit. The first one is in front of you. You have to use the principle of mathematical induction to prove that 2 plus 4 plus 6 till 2n is equal to n into n plus 1 for each natural number n. Now this is the question. You have to prove it that this is true by the by the use of principle of mathematical induction. Now the question arises: what is principle of math? What is That is your basic question. That is, you have to prove by the principle of mathematical induction that 2 plus 4 plus 6 till 2n is equal to n into n plus 1 for each natural number of n. First of all, you have to start with step number 1. In that, what you are supposed to do? In this last term, you have to put n is equal to 1. So you will get 2 into 1 is 2. This 2 comes over here, and on this part you have to replace n by 1. 1 into 1 plus 1 is 2. That means 2 is on the left side and 2 is on the right side. That is true. Step number 1 completed. Step number 2, replace n by k. What will change? Only this n will be replaced by k and this n will be replaced by k. So you will get 2 plus 4 plus 6 till 2k, which is equal to k into k plus 1. Now, you have to write that. That is correct. Now, the next step is replace k by k plus 1. And it's true. So what we will be doing? We will be doing 2 plus 4 plus 6 plus 2 into k plus 1. 2k plus 2k plus 1 is equal to replace n by k plus 1. So you will get k plus 1 over here, and this second bracket will be k plus 1 plus 1. That will be k plus 2. Now this is your first equation. Now what we are supposed to do? Pick this much. 2 plus 4 plus 6, 2k plus 2 into k plus 1. Pick this. Write it over here. Now, in the previous step, you can see that you have the value of this part. The value of this part is k into k plus 1. Put over here k into k plus 1 plus 2k plus 1. Open it and club it. Nothing to do. There is no need of opening it also, because you can see there are two brackets with a plus sign in between. The same brackets are multiple of it. That is, when you take k plus 1 out, you will be left with k plus 2. Straight away, this is in red, is here. Okay, so this is the principle of mathematical induction. But how to close it up? This shows that the result holds for n is equal to k plus 1. Therefore, the truth of pk implies the truth of pk plus 1. The two steps required for the proof by mathematical induction have been completed. So our statement is true for each natural number n. Do remember to write this conclusion step. That is required, and it consists of marking. Your next problem is 1 plus 4 plus 7 till 3n minus 2 is equal to 1 by 2 into n into 3n minus 1, and is true for every natural number n. So first of all, what we will do? We have to pick this part. Replace n by 1. When you will be replacing n by 1, it will become 1. This is this one. Write 1 on this part. 1 by 2 into 1 into 3n minus 1. That will become, after solving, you will get 1. That means on the left hand side you have 1, and on the right hand side you have 1. That means P1 is true. Replace n by k. What will happen? 1 plus 4 plus 7 plus 3k minus 2 is equal to 1 by 2 k 3k minus 1. Here it is. Since P1 is true, Pk will be true. Next step is find Pk plus 1. So you have to replace k by k plus 1. What will you do? This much is there. Here you can see this much is there. Plus 3 into k plus 1 minus 2. Bracket close. Is equal to on the right hand side, what will happen? 1 by 2 into k plus 1 into 3k plus 1 minus 1. If you will be writing with your own hands, that will be easier for you to understand. You have to replace k by k plus 1. And you don't forget that you have to write the previous step. Then you have to write pk plus 1 in on the left hand side. Now what will happen? Just see to it you have the value of this part. This part is nothing, but this part is this. Replace over here, get it, and see to it what you get. I'm just summarizing it. Find P1, PK, PK plus 1. The third step, that is PK1, includes the value of PK. Pick it, you will get right side of PK. This is what you got. Now what I told you, to replace, find this value. Where is this value? This value is here. This plus this. Now here it will come. I've picked up that step, this one plus 3k plus 1. I've left the right hand side over here only. It has been marked. This is what I will be proving. You have the value of this from this step here plus 3k plus 1. This keep 1 by 2 out, simplify it, 3k square minus k plus I've taken LCM of it, so that will become 6k plus 2. 3k square plus 5k plus 2. You have to break up the middle term because this is a quadratic function. In quadratic function, there are two methods of solving it. First one is splitting the middle term. This is what I've done over here. And the another method is by the formula which I will be showing it to you later. Since we have to, first of all, we have to multiply 3 into 2. 3 into 2 is 6. Now we have to find the value of multiples of 6 in such a way that either by adding or by subtracting, we get 5 because we have to break the middle term. So 6 can be broken up as 3 and 2. And when we will be adding them, 3 and 2, we will get 5. So that means this 5 can be written as 5k, can be written as 3k plus 2k. So you can see over here, this 5 has been broken into 3k plus 2k. That becomes 3k square plus 1, 3 by 2, 3k plus 2k plus 2. Now take this 3k common. So here you will be left with k plus 1 plus 2 common for these two values. You will get k plus 1. Now take k plus 1 together and in the another bracket you keep 3k plus 2. This is what is marked over here. So in the conclusion part, what you are supposed to write, this shows that the result holds for n is equal to k plus 1. Therefore, the truth of pk implies that the truth of pk plus 1. This is the closure line, you have to write it. Is that clear? Somewhat clear? No response from anyone. You are doing it or you are trying to understand it. There are two things different. I'm audible to you.
Yes, sir.
Is that clear? Because we will be doing this is somewhat tedious work. We have to do it and we have to follow the same step. We're not going to change anything, but there are three or four different kinds of problems in this mathematical index. The first one is this one.
Okay, sir, it's clear.
Now, the second type problem. We have to use the principle of mathematical induction to prove that 1 upon 1 into 2 plus 1 upon 2 into 3 plus till 1 upon n into n plus 1 is equal to n upon n plus 1. You have Pn, pick up the question, replace n by 1. Where you have to replace it? You have to do it here in this part only. This is the left hand side and this is the right hand side. Replace, you will get 1 by 2 over here. In this part you will get 1 by 2 and when you will be replacing n by 1 and over here again you will be getting 1 by 2. That means left hand side is equal to right hand side. First step is complete. Second step, replace n by k. So what will happen? You will get something like this. Okay, n has been replaced by k. Now P1 is true, Pk has been replaced. Now we will find Pk plus 1. So what we are supposed to do in Pk plus 1. Now see to it, I'm showing it over here only. This is Pk. The next term will be what? Plus 1 upon k plus 1 into k plus 2, which will be equal to k plus 1 upon k plus 2. Is that clear? Now see what happens. Here it comes. This is the step what you were supposed to write now. Because you have replaced k by k plus 1. So you can see over here, this k will be replaced by k plus 1 plus this k will be replaced by k plus 1. So this bracket will become k plus 2. And on the right hand side, k plus, that was k upon k plus 1. So it will become k plus 1 upon k plus 2. Now, you have the value of this part. I'm talking about this part. Your value is k upon k plus 1. Replace it by k plus 1. Replaced plus 1 upon k plus 1 into k plus 2. When you will be taking the LCM of it, you will get k plus 1 into k plus 2. And in the numerator, you will get k plus 2 plus 1. Add up. This is a quadratic equation and this is similar to a plus b whole square. So what I will be doing, k plus 1 whole square upon k plus 1 into k plus 2. This power 2 will be cancelled by this k plus 1. So you will be left with k plus 1 upon k plus 2, which is nothing but this. That means you have proved it by mathematical induction. Have a look at it and I request everyone to write it. If you will be writing it simultaneously with me, it will be easier for you to understand. I'm repeating it. This is what you have written in over here on the left hand side. And you have to add k plus 1. So replace this k by k plus 1. So this will become k plus 1 and this k plus 1 will become k plus 2. And on the right hand side, you have this k upon k plus 1. So that will become k plus 1 upon k plus 2. Leave it, pick this up. You have the value of this part. This part value is k upon k plus 1. Solve it. Take the LCM. Maximum part will come as the LCM. When you will be dividing this by this, you will be left with k plus 2. Multiply k into k plus 2. This is from plus. This is same, you will get 1. 1 into 1 is 1. Now you are left with k square plus 2k plus 1. That is k plus 1 whole square divided by k plus 1 into k plus 2. 1 k plus 1 will be cancelled. So you will be left with k plus 1 upon k plus 2, which is nothing but this. This is what you are supposed to do in proving questions related to mathematical induction of this kind. Now, can you, any one of you can explain me what I did over here? Any one of you who can explain me what I did here in this solution? Who is going to tell me what I have done over here?
Can I say, sir?
Yes, of course. You are free to say, man. Just tell me what has been done over here.
In this question, we will done in 3 steps. At the first, we replace the one. We replace one into n. Whenever we say in everywhere, we will write instead of that one, and after that, we'll replace n by k. When k is true, so the k plus 1 is also true. And the
That is
yes, and the next step is we will replace k plus 1 into n.
now where we have replaced k plus 1 by n.
Yes, by n.
Where?
We replace k plus 1 in here in this page.
What I said? I said this is what we have. We are writing, adding this term. That is, we are replacing it by, we are finding out the next term. So we are adding 1 upon, replacing this k by k plus 1 and this k by k plus 1. So this will become k plus 2.
Yes, sir.
Now we have the value of this part. That is k upon k plus 1. So we will be adding this. Now this becomes over here. Take the LCM of it, you got this. Simplify it, you will get this. This is nothing but the value of k plus 1. Here it is. Since you got the same value, then you can say that our result holds for n is equal to k plus 1. Therefore, it is truth. The truth of pk implies the truth of pk plus 1.
Yes, sir.
This
Sir, I have a question in here.
Yeah.
Can we prove this question by another method?
Which method?
I proved that this question by another way. I will send you in WhatsApp. Do you have do you in your group?
No, I'm nowhere in any group. This is what I'm teaching you, or what I'm telling you, is the standard method for proving the question by mathematical induction.
Okay,
First of
sir.
all,
Okay.
you have no, don't change it anywhere, because first of all, you have to find the value of P1, then
Okay,
PK,
sir. Okay.
then PK plus 1, and you have to prove that with the value of PK plus 1 is true. What is written in the last line? Have a look at it. The result holds for n is equal to k plus 1. Therefore, the truth of Pk implies the truth of Pk plus 1. This is what you are supposed to write.
Okay, sir. Thank you.
Anyone else who wishes to explain the solution or has any question related to it? Because the next one will be too tricky. I will be following the same thing, P1, PK, PK plus 1. But method of proving it will be different, because as per the problem, we have to change the steps. Now here it comes. By the principle of mathematical induction, show that 2 plus 2 raised to the power 2 till 2 raised to the power n is equal to 2n plus 1 minus 2. Now who is going to tell me what you are supposed to do? Method is not going to change, it will remain as it is. Only the question is going to change, and it has been changed. Any one of you who can explain me how you will proceed? The problem is 2 plus 2 raised to the power 2 plus till 2 raised to the power n, which is equal to 2n 2 raised to the power n plus 1 minus 2.
Can I explain, sir?
Yes, most welcome, please.
Okay, sir. We will replace k by n, and the first we will write 2 power k plus 1 minus 2, and then we will replace k plus 1.
My question is, straight away, I told you, first of all, you have to find the value for for n is equal to 1. N is equal to 1 has to be kept over here. This becomes 2. I'm talking about the first step. This is the left hand side equal to, now replace this. You will get what? 2 raised to the power n is what? What will happen over here? N is 1, 2 raised to the power 2 plus 1. 1 plus 1 is 2, 2 raised to the power 2 is 4. 4 minus 2 is 2. That means on the left hand side you got 2, and on the right hand side you got 2. That means Pk is true. Now we will replace that n by k. So your question will become this. Is that correct?
Yes, sir.
Okay. Now next step will be what we will do. Now see what will be the next step. 2 plus 2 square plus 2k plus 2 raised to the power k plus 1 will be equal to 2 raised to the power k plus 2 minus 2. See, you will get over here. Got it? Is that correct?
Yes, sir. It's correct.
So what we have the value of this part. This part will be replaced by this one. And this part will come over here as it is. Now we will be simplifying these. So what we are going to get? We will get 2 times of 2 raised to the power k plus 1 minus 2. Take 2 common. Here, this step, you have to see what has been done and why it has been done. This last three lines have to be taken care of. What is the trick which has been performed over here? You are having this part. This is what you got from. You got from this over here. Here it is. And your k plus 1 is this part. Now you have to solve this to get this. This has to be transformed in such a way that you get this. So first of all, how this will be done. See to it how this has been done. Take this minus 2 out over here. Now this and this will become 2 times of k plus 1. What I'm saying, if base is same, power is added. So 2 raised to the power k plus 1 into 2 will be equal to 2 raised to the power k plus 2. And minus 2 will remain as it is minus 2. Is this clear? Any question from anyone? Is that okay? Can I move? Now, another type of problem. Show that n into n plus 1 into 2n plus 1 is a multiple of 6 for every natural number n. Okay, we are not going to change anything. We will start with n is equal to 1. On the left hand side, replace n by 1. 1 into 2 plus 1, that is 3. 2 into 3 is 2 into 3 is 6. 6 into 1 is 1. So 6 is divisible by, is a multiple of 6. Is that correct? Replace it by k. You will get k into k plus 1 into 2k plus 1 is a multiple of 6. After that, replace k by k plus 1. K by k plus 1 has to be replaced. Now see to it how it has been replaced and what we will be doing. What I did, I replaced k by k plus 1 where? I replaced this by here. So this k will become k plus 1, this will become k plus 2, and this will become 2k plus 3. Here it is. And on the right hand side, it will become k plus 1 into 2k plus 2 into that has been solved, that will become 2k plus 3. Okay. Now, what will you do? You have to club k and k plus 1. So take k plus 1 common. You will be left with k, 2k plus 1 plus 6k plus 1. What has been done over here? This is pure simplification. Simplification has been done. See to it. And the number, this simply keep one thing in mind. There may be different methods of solving it, but since our got 6 over here, so we have to simplify in such a way that we get 6 as a multiple over here. Because in PK we have a multiple, because our statement was it is a multiple of 6. Since after solving we are getting 6 over here, so we can say that because this part is a multiple of 6. That means P, or that is K plus 1, K plus 2, 2K plus 3 is a multiple of 6. So we have to conclude with this statement. This shows that the result holds for n is equal to K plus 1. Therefore, truth of Pk implies the truth of Pk plus 1. That is the closure line. You have to write it with every proof. Now we move to next part, most interesting. Here you will feel comfortable. Now we are talking about sequence and series. First of all, we will start with arithmetic progression. An arithmetic progression is a sequence of terms such that the difference between any term and the one immediately preceding it is a constant. The difference between these two is called common difference. Now you can see a series that is given to you as 3, 7, 11, 15, 19. These are the numbers written over here. Now I just want you to tell me that this is a AP. For AP, what you are supposed to find? First of all, you have to find the first term. First term is denoted by A, which is 3 in this case. Now, since this is an AP, so we will find out the common difference. Now the question arises from where we are going to get the common difference. Common difference will be the difference between the third term, a second term, and the first term. Now tell me, what is the difference between second term and first term? What is the difference between the second term and first term in this problem?
4.
4. Third term minus second term.
-2.
How? I am there only on the first problem. I'm asking you what is the difference between third term and second term in first case. Here we are, when you are subtracting 7 from 11, what you are going to get? What is the difference between 11 minus 7. Okay. Now move to the second series. What is the common difference? Common difference is what? Second term minus 2. Now see, whenever, wherever, either you subtract this and this and this, and this and this, you will always get a same common difference. 3, 4? From where are you getting 3, 4? Throughout the series, the common difference will be same. If the common difference is same throughout the series, that series is an arithmetic progression. In arithmetic progression, basically the common difference has to be calculated, it has to be evaluated initially, and we have to see that the common difference is same throughout the series. If the common difference is not equal throughout the series, that is not an equal. Now, first term is given by A and the common difference is denoted by D. We have to know two formulas in arithmetic progression. The first one is known as term formula and the second one is sum formula. When we are talking about the the term formula, that is either an or tn is equal to a plus n minus 1 into d. Now, we will see how this is used. A series is given to you 7, 11, 15, 19, 23. First term is, what is the first term of this series?
7.
What is the common difference between this series?
4.
What about the second series?
All of these are 4, teacher.
No, that's fine. I'm talking about this part now. What is the first term over here?
A plus 2b.
What is the common difference?
B.
How is that possible? It's wrong. How is that possible, B? How you calculate common difference? First of all, that is the question. What is the procedure for calculating common difference?
A plus b minus a minus 2b will become minus b.
Thank you, madam. That will be minus B, not B. There is a lot of difference between B and minus B.
Okay, sir.
Normally, what you are supposed to do, second term minus first term, third term minus second term will always be same. The difference will always be same. If the difference is not same, then it is not an equal. Now see, now we will apply the formula of a plus n minus 1 into d. You have to find the 18th term, 23rd term, and nth term of the arithmetic progression minus 11, minus 9, minus 7, minus 5. This is given to you, and you have to find the 18th term. 4 terms are being given to you, and you have to evaluate 18th term. So here in the problem, your A is, what is your A? A is the first term. What is A?
Minus 11, sir.
Thank you. What is the common difference?
Minus 9.
Minus 9. How you got minus 9? I'm asking about the common difference.
Minus
How?
2.
How come, madam?
No, sorry, sir, it's 2.
Now see to it how much difference is there between 2 and -2. If you are going to write -2, whole of the problem will be cancelled. I've shown to you how this common difference is evaluated. It is -9 minus of -11. That will become -9 plus 11. That is 2. Correct? Now you have to find the value of 18th term. 18th term means n is 18. And your formula for finding out the term is an is equal to a plus n minus 1 into d. Your a is -11. Your n minus 1 will be 17. And your common difference is d. It will become 11 plus 34. -11 plus 34. That is 23. Now find out A23. Just tell me how it has been evaluated. I'm talking about A23. That is the 23rd term of the series. Yes.
Sir, we are putting -11 instead of A and 2 instead of D. So then we are calculating that.
But it will become -11 plus 44. That is equal to 33.
33.
Now, the third part was to calculate the nth term. So what will you do?
First of all, we will find the term like an. So what is the n? Then we are calculating that. First, we will find the.
Your answer will be in the terms of n only. You
Yeah.
have the value of.
So the same way, we are putting -11 instead of A and 2 instead of D. Then we are calculating.
So you will get 2n minus 13. You will get 2n minus 13 as the answer. 2n minus 13. Okay? Is that clear?
Yes, sir.
First term is A, common difference is second term minus first term, or third term minus second term. Now, the difference of two terms of one AP. Your AP, what is the general form of an AP? That is, you can see over here, you can write it, you have to remember it. I will be using it in different ways. Number of terms, how they are. Actually, how they are in which form they are. That is A, comma, A plus D, comma, A plus 2D, comma, A plus 3D. This is the general form of an arithmetic progression. Now you will say how and why. Your first term is A. What will be the common difference? What will be the common difference of this series? I'm talking about D, correct? Now what about subtracting third term minus second term?
It's also D.
Yes. That means this is a case of a general form of arithmetic progression. Now, my question is, you have been asked to calculate the difference of two terms of an AP. So this is, what is the term formula? Suppose we are finding AR and AS. So AR minus AS we have to calculate. So what we will do, we have the formula of ANS, A plus N minus 1 into D. You will be replacing N by R. Here it has been replaced, and here you will be replacing N by S. Open it up. What will you, everything will be cancelled up. You will get R minus S into D. That is the formula. This is the formula for the difference of two terms of an AP. Okay, now we will see. Which term of an AP, A3, 15, 27, 39, will be 132 more than its 54th term. Very interesting question. How much interesting this is, you can see from here how it has been solved. What is the way of solving it? What is the question? I'm repeating the question once again. Which term of the AP 3, 15, 27, 39 will be 132 more than its 54th term? That means
Sir, it's so common. We are finding n the term, like which term, and until the last we have calculated and we got 65.
how we got it, what we did.
First of all, we know the 54th term, and we need like which term will be more than. So here we don't know about n more than 54th term. So we are just finding the n term. We have the formula there. A n minus a, the term which we know is equal to 132. Then we are calculating the n, and we also have the values, the differences, and the common difference is 12. So we are just calculating that.
That means that is an application of your formula. We are not aware what we have done. We are not aware of the nth term. So that means that will be an minus 54. This 54 term is more. That means the difference of these nth term and the 54th term will be equal to 132. Now going back to this formula, your n is n, s is 54, common difference is 12. Here 15 minus 3 is 12 is equal to 132. Solve it and find out the value of n. Now remember one thing, n will always be a number. It will never be in a fraction or a negative number. If in any case you are getting it, that means you are doing some calculation mistake, and will always be a positive number. Is that clear?
Yes, sir.
Okay. Now see. If pth term of an AP is Q and the qth term is P, show that rth term is P plus Q minus R. Number one. And secondly, you have to find the value of P plus qth term. We don't have the first term, we don't have the common difference. What we will be doing? And it is very much clearly written in the problem that this is a case of an arithmetic program. So first of all, what we are going to do? We are going to assume your common difference as D, and we will try to calculate the value of D first. Oh, that's great. Good information. So you can see to it what is given to us and what we have with us. It says that pth term is Q and qth term is P. We have to find the rth term first, and we have to show that rth term is P plus Q minus R. So what we are doing, AP minus AQ is equal to the difference into common difference. So from this you can find the value of D, which is equal to minus 1. Correct? Replace it with AR. AR minus AP is equal to, replace the value of D by minus 1. You will get what after simplification? you will get Q minus R plus P, which is reshuffle it P plus Q minus R. AP, bring that, replace the value of R by P plus Q, what you will get? 0. Got it?
No.
Sir.
No. What is the problem then? AR is equal to AP minus R plus P. That is pure simplification. I've just shifted this over here, and rest is here. Signs will change. When you will multiply R minus P with minus 1, it will become minus R plus P. Okay, but I have to listen to everyone. And if you have any problem, question, then it's my job to answer it. That at that moment only. So this you can see, it's very much over here. I'm just reshuffling it. That means AR is equal to P plus Q minus R. That was asked. Rth term is P plus Q minus R. First part has been proved. And secondly, with that, we will prove P plus QS term. P plus QS term will be 0 because we will be replacing R by P plus Q. As we will do that, your AP will become 0. Another problem. If m times the mth term of AP is n times its nth term, show that m plus nth term of an AP is 0. Okay, so we have the term formula, that is now here I'm using Tn in place of an. That doesn't make any difference. That is one and the same thing. Tn is equal to a plus n minus 1 into d. That is for nth term. And for the nth term, it is a plus n minus 1 into d. What is there in the problem? M times the mth term, that is ntm, is equal to n times of nth term, that is tn. In the red, you can see that it is mtm minus is equal to ntn. Replace the value of tm. Tm is a plus n minus 1 into d. And replace the value of tn in the right hand side. You will get a plus n minus 1 into d. Open it up. That doesn't make any difference because you have to prove it to be 0. So you can keep 0 on the right side and bring every part on the left side. Now that opening up has to be done by you. And after simplification, what you will find that you have to break up in that case in the form of a plus m plus 1 minus 1 into d, because you have to find tm plus nth term. So it will be a plus m plus n minus 1 into d. We have just transformed it. This transformation has been done for this purpose, because your tm plus 1 will be this. Value of this is 0. That means you will get tm plus 1 equal to 0. What was asked in the problem. Is that clear?
Yes, sir.
I hope everybody is writing it simultaneously. Is that correct, or you are just listening to it how to solve it?
No, sir, it was so clear for us.
Okay. But because I always say uh, that is correct, but as far as mathematics is concerned, you should write it with your own hands simultaneously. Because sometimes there are some steps which we normally forget. I'm grateful that you understand what I'm teaching you.
Sir, I have solved this question by myself, and I will share the notes of myself in our group.
You have solved this question.
This unit, the block to unit 1.
Okay. Now we will move to another formula. There are two formulas for the sum of n terms of an AP. First formula is S is equal to n by 2 into 2a plus n minus 1 into d, where and which formula for the term n will be provided to you, a will be provided to you, and d will be provided to you. A is the first A is the first term, D is the common difference. And on the right side, you can see that there is another formula. S is equal to n by 2 into A plus L, where L is the last term of the series.
So here, if we don't know the last term, then we are going for the second formula. If we don't know the whole summation, then we are going for the first formula.
You can say that. I will show you how this. I will show you both the application of both the formulas. And it's because second formula is used in typical problems. Normally we use Sn is equal to n by 2 into 2a plus L, n minus 1 into d in mostly general cases. Now see to it. Your first problem is find the sum of first 100 natural numbers. So what will be the first term?
We know the first one, that is 100. N will be 100,
Okay.
and the first term is 1 because we are
Okay.
starting from 1 to 100.
What will be your common difference?
Common difference, we are just going like from 1 to 2. 2 minus 1 is 1. 3 minus 2 is 1. It will be 1.
Okay. So straight away you can apply the formula.
Yeah, then we are applying on the first formula, and we will get the 100 natural numbers, summation of 100 natural numbers.
That means you will be replacing n by 100, a by 1, and d by 1. Is that correct?
Yes, sir.
Okay. The answer is in front of you. Can we apply this formula in this problem, this formula in this problem?
Yes, sir.
How?
We can.
How?
In that case, we will say like we have the summation 5050, and
No. My question is,
uh,
the problem is this. Find the sum of first 100 natural numbers.
Yes,
Can,
sir, we can
can
we
we
can
apply
solve
this?
this question.
Can we apply this formula? If yes, then how?
Yes, we can, because we have the first term and also the last term of the question. The first term is 1 and the last term is 100.
Excellent. And your n is 100.
Yes, sir.
100 plus 1 is 101, and into 50 you will get the same thing. 50 into 50. Okay. Now comes the another problem for you. Find the sum of 23rd terms and the nth term of the AP. AP is given to you 16, 11, 6 and 1. First of all, you have to find A. What is A?
16.
What is A?
A is the first
Yes.
term, and
What is D?
D is -5.
Okay. Which formula we will be using?
We don't have the last term, so we can use the first formula.
Yes, madam. What is the first formula?
It was Sn equal with n by 2, and 2a plus n minus 1 multiplied with d.
Okay. Your N is 23, your A is 16, and your common difference is -5. Is that correct?
Yes, sir. Yes, sir. It's correct.
And the solution is in front of you. Is that clear?
Yes, sir. It's clear.
The second part was to find the nth term of this AP. So what will you do? You have to find the sum of the nth term. It's very simple and very clear. Replace n by n, a by 16, and d by -5. Solve it. Is that clear?
Yes, sir.
This is what we are supposed to do. The question says that you have to find the sum of 23rd term, number one, and the sum of nth term. In nth term case formula, what you will be doing, your n will be replaced by n, and your a will be 16, and your d will be -5. Now in this case, your answer will be in terms of n only. Right? Now see, how many terms of an AP 147 must be taken so that the sum may be 715. Straight away go to the problem. It is a case of AP. So first of all, if it is a case of AP, you have to find the first term. Initially, what we are supposed to do, we have to find first term, we have to find common difference, and then we have to see what else is given to us in the problem. Here in this problem, we have the series and the sum. Sum as Sn means, sum means Sn, and which is 715. You have A equal to 1, D equal to 3. And your sum formula is Sn is equal to n by 2 into 2a plus n minus 1 into d. What you are supposed to find? N.
We are finding n here.
Is the
Which
question
term we?
term? Yes.
Yeah.
Yes. Yes. Now the thing is that while you will be solving it, solve it very carefully, because you can see a number is very big. That is 1430. As you can see, the equation is 3n squared plus n minus 1430 equal to 0. This is a quadratic equation. And in the box in the right hand side, I have written the general formula by which we find the value of x. This is x is equal to minus b plus minus under root b square minus 4ac upon 2a. This formula can only be applied when b square minus 4ac is either equal to 0 or greater than 0. If this is less than 0, we cannot apply this formula. I am repeating it. This is basically for a quadratic equation, and the general form of the quadratic equation is ax square plus bx plus c equal to 0, and the solution for it is x is equal to minus b plus minus under root b square minus 4ac upon 2a. This is the second method by which we can find the value of x in a case of a quadratic equation. This formula is applicable when the value of b square minus 4ac is greater than 0 or equal to 0. If in any case it becomes in negative, you cannot solve it right now over here. Later on, you can solve it, but right now we won't be finding its value. Okay, now going back to the problem, your A is 3, B is 1, and C is minus 1430. Don't make a mistake of neglecting this minus sign, because this standard value of C is plus, but here in your problem it is minus. So you have to take minus 1430. Yes, what is your question? Here you can see your A is I forgot to keep minus over there. Your A is 3, B is 1, and your C is minus 1430. Replace it. What you will get? N is equal to minus 1 plus minus under root 1 minus 4 into 3 into minus 1430 divided by 2a. 2a is 6. Now your question might be there, how to, I've written plus and minus. So at one value I will take n as plus, this as plus, and in the second I will take it as minus. So after solving this is minus 1 plus minus 132. So I will get n is equal to 22 or minus 65 by 3. We cannot take a number in negative form or in fraction form. So that means we have to neglect that, and we will be getting what we will be getting. N is equal to 22. Now see, if in an AP, A is 2, see to it, very applicative problem is, if in an AP A is equal to 2, and the sum of first 5 terms is 1/4 of the sum of next 5 terms. This is the condition what is given to you. And you have to show that 20th term of that series is minus 112. Fine. We know that in general cases, what is the general form of an AP? General form of an AP is A plus D, A plus 2D, A plus 3D. Correct? It was told to you that the sum of first five terms. The first five terms will be A plus D, A plus 2D, A plus 3D, A plus 4D is equal to S5, correct? And the next five terms will be A plus 5D, A plus 6D, A plus 7D, A plus 8D, and A plus 9. What it says, if an AP A is equal to 2, the sum of first five terms is equal to 1/4 of the sum of the next five. First of all, we have to find S10 minus S5. Now, what does this condition say? States fifth term. Fifth term is equal to 1/4 of S10 minus S5. We will be simplifying it. Now the question is why we are doing it. What is given to us? Common difference is given to us. And we are talking in terms of terms. So S5 is equal to 1/4 of the difference of the next five terms. This was given to you. Simplify it, cross multiply it, you will get 4 S5 is equal to S10 minus S5. Bring that S5 on the left hand side. You will get 5S5 equal to S10. Write the value of S5. 2A plus 90. Find the value of D. D is equal to minus 6. Now you are supposed to find the value of A20. You have A as 2, D as minus 6, and your N is 20. So your formula will be 2 plus 19 minus 1 into minus 6. You were calculating S20. We are 19 over. This comes out to be minus 112. Now, if the sum of first n terms of an AP is given by Sn is equal to 2n square plus 5n, find the nth term of the AP. What is given to you? Sn is given to you. Sn is given to you as 2n square plus 5n. And we are using the formula An is equal to Sn minus Sn minus 1. Then what we will be doing? We have Sn, we have to replace n by n minus 1 in this formula. So we will be doing this thing. Sn will remain as it is, minus with 2n minus, because n has been replaced by n minus 1. So it will become n minus 1 whole square plus 5 times n minus 1. Open it up. A minus b whole square is a square minus 2ab plus b square. Open it up. When you will be opening it up, so this 5n will get cancelled with this 5n. 2n square will be with this 2n square. You will be left with 4n minus 4n plus 3. That is nth term. The nth term of the AP will be 4n plus 3. Now you can see that this is basically an application of formulas. You have to remember for arithmetic progression, what is A, what is D, what is given to you, and in which form it is given to you, and which formula. There are 3 or 4 formulas what we have discussed today. Those formulas are being applied. and your imagination. Now see, another problem comes. Find the sum of all integers between 100 and 1000 which are divisible by 9. So can any one of you tell me the first number after 100 which will be divisible by 9?
108.
Last number.
Last number 999.
Okay. Then what will
999.
then what will you do? You were asked to calculate the sum of all the integers between 100 and 1000. You are aware what will be your A?
A is 108. D
What is
is
the
9.
common difference? What
Common
is the
difference is 9.
sorry? What is the common difference?
Common difference is 9.
Okay. And what is the last term? 999.
Last term is 999. At first, we have to
And the
find the
formula will.
value of n.
So how will you find the value of n?
We can find the value of n by formula. An is equal
Which
with
formula?
An is equal with a plus n minus 1 into d.
Okay, so you will get n is equal to 100.
Yes, sir.
And your formula will be s is equal to 100 by 2 into 108 plus 999. After
And
calculation, you will get.
yes, sir. The question wants from us the summation of the terms. So the next formula is Sn equal with n by 2 multiplied with L a plus L. Because we have the first term and also the last term, we can use from this formula.
Can we use that formula n by 2 into 2a plus n minus 1 into d over here?
Yes, sir. We can use from that also.
Because that will be tedious.
Yes, it will be.
Because you have n is equal to 100 and n minus 1 will be 99. Your common difference is 9 and 2a will become 216. So that will become somewhat tedious. So that is why we have used this formula. Okay.
Yes, sir. It's correct.
Now we move to next part. That is geometric progression. Progressions are of various types, but basically we have arithmetic progression, geometric progression, harmonic progression. Now the second thing is geometric progression. You are aware of that we used difference in arithmetic progression. Now here we will be using the word ratio. Ratio means division. Difference means difference. How to remember it? In arithmetic progression, we were supposed to find the difference. And in geometric progression, we will be finding out the ratio. There, in arithmetic progression, first term was A. In geometric progression, first term will be A. But in arithmetic progression, we were finding the difference of the second term and the first term. Here, what we will be doing in geometric progression, we will be dividing third number by the second one, or the second one by the first term. That means in geometric progression, we will be having common ratio. Common ratio is denoted by R. And in arithmetic progression, we were having common difference. Difference is denoted by T. There, in arithmetic progression, we had A plus D, A plus 2D. Here, we will be having AR plus AR square plus so on. Again, 2, 3 formulas will be there. The first one is for the term. For the term is again given by an or tn, which is equal to a plus r raised to the power n minus 1. Is that correct? This is the first formula for geometric progression. What we are supposed to do in geometric progression? We have to be very clear that first term is given by a and we have to find the common difference. Common difference is found by second term divided by first term or second term, third term divided by second term. It will remain same. Now, there we found that difference. Here we will find the ratio of two terms. Here it will be an upon am is equal to r raised to the power n minus m. Now here it comes. If r, find r, and the next four terms of the GP. This is minus 3, 1, minus 1 by 3, 1 by 9, and so on. What is A? This is a case
Minus
of GP. So you have, A is minus,
3.
and what is R?
R is minus 1 by 3.
Thank you. You are given the four values. What will be the fifth term?
The formula is A5 equal with A4 multiplied with R. So we have the if
You see that I'm not going to apply the formula. This is what it has to be seen. You can see that four terms are given. Okay. Now I tell you what is the
yes,
trick
yes,
of
sir.
solving it. Four terms are given to you. You are being asked to find the next fourth term. The fifth term will be a multiple of this term, of the fourth term. So
Yes,
A5
sir.
will be equal to A4 into R. Why I should apply the formula?
Because it's easier than formula.
Next, A5 multiply that by minus 1 by 3. Common ratio. It is the case of common ratio. You have to multiply by common ratio. Multiplied by common ratio. You will see that first term is of minus. Second term will be of plus. Third term is of minus. Fourth term is of plus. Fifth term will be of minus. Sixth term will be of plus. Seventh will be of minus. And eighth will be of plus. Alternate. And the ratio will remain same throughout. You can check it whether you have done it correctly or not. If you are going to divide A8 by A7, what you are going to get? If you are going to divide A7 by A8, what you are going to get?
Common ratio.
Common ratio, yes, correct. And what is the common ratio?
Minus 1 by 3.
Thank you. Now, any question from anyone? What we have learned today? No question from anyone. Very good. It becomes very interesting part when you say no question. That means in that case, two things come up. Whether you have understood everything or you have not understood anything. Where I should keep it? Everything or nothing?
Everything.
Oh. So that means we have covered up determinants, matrices 1, matrices 2, mathematical induction. Today we started with block 2, that is algebra 2, sequence and series. And then sequence in C is I've completed arithmetic progression, started geometric progression. Now, my question is, do you have any problem in the last 4 units what we have discussed? Either it is of determinant, matrices, induction, or arithmetic progression. If you have any problem, just let me know.
Sir, can you please share your phone number for us, because we will have problems in our lessons every time we can share with you.
My phone number. You want my phone number? Okay. That is
Your
70.
WhatsApp number.
How about that is 70 double one 98 85 85.
Can you repeat it, please, sir?
7011 98 85 85.
Yes.
Okay. So
Thank
can
you,
we?
sir.
Okay. Most welcome. Can we conclude today's session?